partial differential equation, and we know differential equation is of have two different forms. First is ordinary differential equation, and next is partial differential equation. And in case of ordinary differential equation, there is one dependent variable and one independent coordinate. Okay, but in case of partial differential equation, there is one dependent coordinate and more than one independent coordinate. So there is these are some examples of partial differential equation. The first order Laplace equation, del square psi is equal to 0, and the Poisson's relation, del square psi is equal to rho, and time dependent Schrodinger equation, h psi is equal to e psi, capital H. H psi is equal to e psi, and x psi is 1 by h square dou psi by dou t. And wave equation, dou square psi by dou x square minus 1 by c square dou square psi by dou t square is equal to 0. And Helmholtz equation, dou square psi by dou x square plus, this is in the first one-dimensional case, dou square psi by dou x square plus or minus k square psi is equal to 0. Or in three-dimensional, del square psi plus or minus k square psi is equal to 0. So solution of partial differential equation. There are 4 different techniques for getting the solution of differential equation. Dealing with separation of variables here, or variable separable method. And next method is integral solution and method of numerical calculation. So we can do one problem using method of separation of variable. So here is the question: find the solution of a given differential equation by the method of separation of variable. The differential equation is 2x into dou u by dou x minus 3y into dou u by dou y is equal to 0. Here u is the dependent variable and x and y are the two independent variable. Okay, so this can be written as u is equal to u of xy. And u of xy can be, we have to separate the variable. X and y are the x part and y part. We have to separate the variable. So u can be written as xy. U y, where x is depends on x only and y is y only. So we can substitute this equation 2 in equation 1 instead of u. And equation 1 becomes 2x dou xy by dou x minus 3y into dou xy by dou y is equal to 0. Now we know that this x is depends on small x and capital Y is depends on this y. So we can write 2x into y dou x by dou x minus 3y into x dou y by dou y is equal to 0. We can divide both sides of the equation by xy, then 2x by x into dou x by dou x minus 3y by y into dou y by dou y is equal to 0. So in this way, we can separate the variables. X part on the one part and y is on the another part. In this way, we can separate the variable. Now let's equate these two equations to a constant. Okay, for x, if k1 is a constant, I am taking k2 is a constant for next equation. So dou x by x into dou x by dou x is equal to k1, and sorry, this is not dou x, it is 2x. Sorry, this is 3y by y into dou y by dou y is equal to k2. So in the first equation, from this equation we can write dou x by, here these two are capital X, dou x by x equal to k1 into dou x by 2x, and here dou y by y is equal to k2 into dou y by 3y. So we can integrate both sides. this integration, and here also we can integrate. Then in the first part, this integration, log x equal to k1 by 2 into log x plus log c1, and k1 by 2 is constant. I'm taking then 1 by x into dou x, or we can actually it is dx now, dx is dx because it the x is depends only on x now, and here also dx. First equation, this one, k2 by 3 log y plus log c2. Therefore, from this equation, log x equal to k by 2 log x plus log c1, and log x raised to k by 2 plus log c1, and log x equal to log x raised to k by 2 into c1, or x equal to x raised to k by 2 into c1. So this is x. Now we can find out what is y. The equation is this one, and log y k raised to 1 by 3, y raised to k by 3 plus log c2, or log y raised to k by 3 into c2, or y is equal to y raised to k by 3 into c2. Now we got the solution because u is equal to x and x into y. Okay. Now we got the values for y and x. Therefore, in this equation, u is the solution. Here, u is the solution. We can find out the solution u of xy. U xy is equal to x into y. We find out the values of x and y. Now we can substitute there. Then we will get x raised to k by 2 into c1 into y raised to k by 3 into c2, or x raised to k by 2 into y raised to k by 3 into c, where c is c1 into c2. So this is the complete solution of the partial differential equation by the method of separation of variable. And by method of separation of variable, we have to understand these steps. That is, first one is u is equal to u x y z. Then we can take u as u x u y z, and x is depends on x only, y depend on y only, and z depends on z only. Then now we can put the function in partial differential equation and separate each partial differential equation separately equated to a constant. Then method of integration solution of each variable found out, and each solution is combined to get the complete solution for function u. So we can see another example from here. Solved by the method of separation of variable. The question is, this is our equation, dou u by dou x equal to dou u by dou y. We have to find out the solution u. So u of xy can be written as xy, that is u is equal to x into y. First, the first one, dou u by dou x. Dou u by dou x can be written as dou xy by x, where because u is xy, instead of u, I substitute xy, and y into dou x by dou x. Then dou u by dou y can be written as dou xy by dou y is equal to x into dou y by dou y. That is equation number 3. Now, equation A becomes, this can be written as y into dou x by dou x equal to x into dou y by dou y. So, dividing both sides of the equation by 1 by x by dou x equal to 1 by y by dou y, which can be equated constant. Okay, k. I take k here. Then the first equation, this equation, 1 by x by dou x equal to k, and here dou x is dependent on only x. Therefore, I can take it as dx instead of dou x. I can take it as dx by x equal to k into x. Okay, I brought this dx. So dx by x equal to k into dx. Now we can integrate this equation. And log by c1, which is equal to kx, or x by c1 is equal to e raised to kx, x equal to c1 into e raised to kx. That is equation number 4. In the same way, we can equate this equation to a constant. Okay. Therefore, 1 by y is equal to k. And we will get y is equal to c2 into e raised to ky. So that is equation number 4 and 5. So we can substitute equation 4 and 5 in equation number 1 because we got the value of x and y. Then when we are substituting, yes, the solution becomes u is equal to xy. That is u is equal to c1 into e raised to kx, c2 into e raised to ky. That is the solution is c into e raised to k into x plus y, where c is equal to c1, c2. Now next problem, dou x into dou u by dou x plus y into dou u by dou y is equal to 0. Where the same method, u is equal to xy, x into y dx by dx plus y into x dy by dy is equal to 0. That is xy dx by dx is equal to minus y into dy by dy. I dividing this equation by xy, then x by capital X into dx by dx equal to minus y by y into dy by dy, which equated to a constant. Then the first equation, x by x into dx by dx equal to k, or dx by x equal to k into dx by x. Therefore, log x equal to k log x plus log c1. I am integrating this equation. Now log x by c is equal to log x raised to k, or x by c1 is equal to x raised to k, or x equal to c1 into x raised to k. That is equation number 3. Now we can take this equation equated to a constant k. That is minus y by y into dy by y is equal to k. dy by y is equal to minus k into dy by y, or log y is equal to, I am integrating this equation, then log y is equal to minus k log y plus log c2, or y is equal to c2 into y raised to minus k. Okay. Now u is equal to x into y. The values of x and y k into c2 y raised to minus k, or u is equal, we can written like this, c into x by y raised to k, where c is equal to c1, c2 is equal to c. Another problem, dou square u by dou x square minus dou u by dou y is equal to 0. Substitute u is equal to xy. So dou square xy by dou x square minus dou xy by dou y is equal to 0. Y into dou square x by dou x square minus x into dou y by dou y is equal to 0. Dividing the equation throughout by xy, then 1 by x dou square x by dou x square is equal to 1 by y dou y by dou y. So we can take this first equation and equate it to a constant. Then 1 by x dou square x by dou x square is equal to k. So we can find out this equation. 1 by y dou y by dou y is equal to k. From this we will get y is equal to c to e to ky. Now take this equation. 1 by x square x by dou x square is equal to k. Dou square x by dou x square is equal to kx. Dou x minus this auxiliary equation. So we can substitute, instead of dou square x by dou x square, I substitute d square. That is d square minus k is equal to 0. D square minus, that is d square minus k into x equal to 0. Here into x equal to 0. that is d square minus k is equal to 0. So d square is equal to k, or d is equal to plus or minus k. And in this type of equation, we have the solution, auxiliary equation, we have this equation solution, x equal to c1 into e raised to root of x kx plus c2 into e raised to minus root k into x. So we got the solution y and x and y. Then we can substitute in equation 2, that is u is equal to c1 into e raised to root k into x plus c2 into e raised to minus root k into x into c3 e raised to minus ky. So this is our solution. Next, if we there is a initial condition in a problem. If there is an initial condition, then we need to apply the initial condition in the solution. Okay. To find out the constant, to find out the value of constant, we have to use the initial condition. So in this problem, 3 into dou u by dou x plus 2 into dou u by dou y is equal to 0. Here it's given a initial condition, that is u x0 is equal to 4 e raised to minus ex. 4 e raised to minus x. Here x0 means here y is equal to 0. In this case, y is equal to 0. So in the last part, we have to apply this initial condition. Three into dou x by into dou by dou x of xy plus 2 into dou by dou y of xy is equal to 0. That is 3 into dou x plus 2x into dou y by dou y is equal to 0. Or divide by xy, then we will get this equation. Okay, this one. 1 by x, we can take this equation. 1 by x dou x by dou x equal to k, or dx by dx. We can change this partial to ordinary differential equation, that is dx by x equal to k into dx, log x to log c1, or x equal to c1 into this one, that is 2 the solution is this one. Okay. Now we have to apply the initial condition to find out the value of k and c. Instead of c1, c2, we can combine and we can give a constant c. Okay. Or u x is equal to 4 into e raised to minus x. Here y is equal to 0. So equation 4 becomes, this equation becomes 4 into u is this one. So instead of u, I substitute this one. 4 into e raised to minus x equal to c1 c e raised to x. Here y equal to 0. Therefore, this term becomes 0. And c is equal to 4. We can combine, equate the coefficient of e raised to kx. Okay. So c1 c is equal to, and taking minus kx. So here the value k minus 1. So now the equation becomes u is equal to 4 into e raised to minus x plus 3 by 2 into, this equation becomes, this equation becomes 4 into e raised to minus x plus 3 by 2. We can in this form.